When we talk about the cloud, streaming video, or wireless data, the picture in our heads is usually pretty airy. We imagine our messages and movies floating invisibly through the sky, beamed down to us from satellites orbiting the Earth. Treating the internet like an invisible, magical force creates a broken mental model. It leaves us staring at our screens, totally disconnected from the physical reality of how our world actually communicates. The truth is that global data transmission depends on physical, underwater transit. To get a message from one continent to another, we have to send it across the ocean floor. Right now, almost all international data is traveling through a vast network of garden hose-sized cables. They are covered in protective steel and plastic, lying directly in the mud at the bottom of the ocean. The internet rests on the ocean floor. These thousands of miles of armored conduit make up a physical backbone that connects every continent. To see how this massive physical machine actually works, let's track a single piece of data starting from the exact second you hit enter on a website address. Your computer doesn't actually understand the human-readable words in that web address. To find a web page, it needs exact physical coordinates, known as an IP address. To cross that language barrier, your browser relies on the Domain Name System, or DNS. You can think of the DNS as a dictionary that translates the words you typed into the numerical location of the server hosting the site. Look at this flowchart. The web address you entered runs through the DNS directory, which then translates it into a specific IP address and draws a direct line that pinpoints the exact physical server where your data lives. This hidden translation process is the only bridge connecting our abstract human language to the rigid physical hardware of the global network. Now that your request has found the target server halfway across the globe, that machine has to send the web page back to you. But it cannot send a high-resolution video or a complex web page back as one massive continuous file. That massive file would clog the network instantly. Instead, it uses the Transmission Control Protocol, or TCP. This mechanism shreds the entire web page into thousands of tiny, manageable data fragments called packets. Imagine trying to mail a thick hardcover book by forcefully ripping out every single page, handing them to thousands of different postal workers, and telling them to run to the destination taking completely different routes. That is exactly what happens. Those thousands of individual packets are forcefully shoved into the physical deep-sea cables we talked about earlier. The packets travel thousands of miles at the speed of light, bouncing through a maze of different physical routers resting on the ocean floor. Sometimes physical interference gets in the way. A router might fail, an anchor might drag the line, or a shark bites the cable. When these traveling data fragments are destroyed, we experience what engineers call packet loss. A glitching video game or a buffering stream is the visible symptom of these data fragments being physically destroyed in the deep sea. Eventually, the surviving packets emerge from the ocean network, hit the coastline, and make the final sprint to your local device. Your computer catches all these scattered, out-of-order fragments and stitches them back together like a jigsaw puzzle to render the complete web page on your screen. Your phone's Wi-Fi connection serves as the final link in this chain, bridging the last few feet between the global wired network and your device. Look at this schematic tracing the connection backward. Your wireless router is secretly plugged into a wire running through your house wall. That wire connects to the street runs to the city hub, and that hub routes directly down into the ocean. This continuous line across the seabed terminates in a physical server rack. When we talk about the cloud, we are describing a remote computer sitting in a climate-controlled room. The internet is a global system of physical plumbing. Recognizing the hardware behind the screen replaces the abstract mystery of wireless data with a clear view of the physical architecture connecting us.